Yes. Coming to the class, in the previous class, I think I have given one problem. Have you solved the problem? What are the answers? Then, what is asked? Moles of R produced. How many got 5.6? How many got? Only one. Open the problem. Where you are finding the difficulty, let's solve it. So, though we not solve the complete problem, but at least give me the hints so that you can attempt. See, this is a parallel liquid reaction given. A gives rise R and then A gives rise S with two different rate constants K1 and K2. He given the values of K1 and K2. He given the values of Ca0 and Cr0 and Cs0 values. Fine. He has asked find the moles of R produced. Find the moles of R produced. So for parallel reactions, we already know two equations. So whenever parallel reaction is there, the equation should come into our mind. What is the equation? Minus ln Ca by Ca0 is equal to K1 plus K2 into T. That's the first equation we should have mind. Second one. Pi Cs minus Cs0 is equal to K1 by K2. So two equations. Fine. Two equations. So we could able to grab those two equations to find out what he has actually asked. Now use the first equation. Minus ln Ca by Ca0 is equal to K1 plus K2 into T. Now in that we know the T given as 15 minutes. We know K1, we know K2, we know Ca0. Can't you get Ca there? Okay. So using the first equation, get Ca value. And that Ca value is, if you could find out, it will be around 1.994 moles per liter. So from the first equation, calculate Ca, keep it aside. Calculate Ca, keep it aside. From the first equation, what is the equation? For parallel reactions, minus ln Ca by Ca0 is equal to K1 plus K2 into T. So you know T, you know K1, you know K2, you know Ca0. Estimate Ca. Keep it aside. Now let's come back to the second equation. What is we have? Cr minus Cr0 by Cs minus Cs0 is equal to K1 by K2. You know K1, you know K2, you know Cr0, Cs0, given zeros. So what you will get? Cr by Cs is equal to 6.5. Okay. So you got something Ca is equal to around 1.994. Right? And then you got Cr by Cs is equal to 5. 6 point? Around 2.5. Now let's come back to the question. What is the question asked? Moles of R produced. So how to get moles of R produced? What to get? You understand first what is the parallel reaction, then every question can be answered easily.
So any concentration of Ca more times one of area.
So you know Cn.
2 months. 8 months.
Given given moles per liter. So you know CA0, you know CA, final concentration. From this, you can estimate number of moles of A reacted. Fine. So what is initial minus what is final you got? So that is your moles of CA reacted. See how many moles of A reacted will be equal to the how many moles of R or S produced. Is it not? Is it not? The question asked is K1, K2 given, CA not given, CR not, CS not given. Fine. And he is asked to find out the moles of R formed. Yes, correct. So now let's understand first. See, A is reacting to form R, A is reacting to form X. How many moles A reacted? That will be on the product side. Is it not? See, I started with some concentration of initially from 8.5. I started with some concentration as 8.5. And finally, I reached the concentration as 1.94 from the equation. So, what I get? I'll get how many reacted? How many reacted? What is the value? Around 6.5 is reacted. So, this much reacted means, is it not that 6.5 is equal to the moles of R in S? See, how many reacted? A reacted is 6.5. That's what we understood. 6.5 moles per liter is reacted. So this much of A reacted means definitely it has to lead to product R and S. So the concentration of R and concentration of S should be the number of moles reacted. Is it fine? Now you know CR plus CS is equal to 6.5. CR plus CS is equal to something value. Can't we get CR and CS? We want only CR value. Understood? See, when A is reacting to form R, same A is reacting to form S. How many moles of A reacted you have calculated? How you calculated moles reacted? Take initial and take final. Final you got from the equation. So how many reacted? You subtract the initial minus final. That's the number of moles reacted. Now this much of moles reacted means definitely this much should be formed either R or S. Fine. So that's what 6.5 forming CR and CS. So two equations, two unknown. Okay. So note another problem. From the following data, for the decomposition of N2O5, the decomposition of N2O5 in carbon tetrachloride solution, in carbon tetrachloride solution, at 48 degrees centigrade, it seems to be first order. Justify the reaction sequence. Justify the reaction sequence. Yes, sir. From the following data for the distribution of N2O5 in carbon tetrahydride solution at 48 degrees centigrade seems to be first order. Justify the reaction sequence. So the reaction given is N2O5 gives rise N2O4 plus half O2. Read the problem carefully. Read carefully the problem. So you have already mentioned it's a first order. That's okay. But we need to confirm. He's asking justify. So once you confirm, the reaction sequence is to be confirmed. Okay, how do we justify? Have you given any time versus concentration data? No. It's time versus concentration data given. We simply have to increase but here there is no concentration data given. History has given the volumes. Now, how do we justify? Samra? Volume wasn't important. What inside the structure? Inside the inside times and also 10 minutes, 15 minutes, 20 minutes, 25 minutes, 1 hour, 2 hours, 1 year, 2 years, 100 years. Infinite time. That means complete reaction decomposes to form N2O5 dioxide. Then what is formed is given. Is given. Is it not? Volume and infinite is almost equal to the initial concentration what we have. See, we how it started. If I give enough time to react, that will be far more successful. Start చేస్తే అది అర్థమైంది 10 ప్రాజెక్ట్ వెళ్తున్నాను సో 10 minutes if my concentration started if I give enough time for reaction almost like infinite time if I give and what will be the volume form will be my initial concentration. Now let us assume this is that's all this is to have taken. This is to be a reaction which is influencing the reaction. Then what could be your reaction is a reaction form two. That is to have taken. N2O4 is not at all substantial in the reaction. Then whatever N2O5 has started will be leading to formation of O2. If I assume like that, then whatever I start with the concentration is equal to the concentration at the end of the reaction that is infinite. Now Ca naught, I can substitute as volume at infinite time, and Ca like volume at infinite time minus volume at any time t. Volume at any time t, volume at infinite time, so remove and concentration of N2O5 because these are volumes of oxygen, not volumes of N2O5. But we want concentrations of N2O5 the equation. Is it okay? What does this equation represents? LNCA not Ca or minus LNCA, that means concentration of the reactant. But he has given volume oxygen, that means product he has given. So if I rearrange this equation in this form, now everything that is given, if you look at volume inequality is known, volume inequality is known, just substitute for different values and if K's are same, and whatever we given the first order is correct. If K's are different, it will be wrong. Check. Check for first one. Check for first one. Check for t is equal to 10. First data for t equal to 10. For t equal to 10, substitute ln V infinity, that is 34.75 by 34.75 minus 6.30. 0. Now calculate second one. Second K.
minutes.
198. It's almost 0.02. Huh? Check for other K value. Check for fourth K value. K values. So now it is the first order. Whatever he said is correct. Is it okay? All the cases are the same. The concentrations of a compound. The concentrations of a compound undergoing a chemical change where 5.72, the concentrations of a compound undergoing chemical changes were 5.72, 3.23 and 1.96 moles per liter. Moles per liter at times 0, 20 and 50 minutes. At times 0, 20 and 50 minutes from the commencement of the reaction. From the commencement of the reaction, the concentrations of a compound undergoing chemical changes were 5.72, 3.23 and 1.96 moles per liter at times 0, 20 and 50 minutes from the commencement of the reaction. Find out order of the reaction. So read problem carefully. What is given? What is asking? Concentration versus time data is asking the order. How do you proceed? We have done so many problems. How do you proceed? How do you proceed? Uh, గ్రాఫ్ గీస్తారా? So no need to plot any graph. First assume any order and accordingly you find out k. If reasonably you will get the case, that is the first order. If there is no first order, go to the second order. Find out k from the second order equation, whatever the data given, substitute, plug in, and if the k's are same, that will be your order. Check. So CLR given, yeah, CLR given. So time is one. So estimate k, get 2k value. At least they are same or not. Check. I will first order it won't fix. So check the second one. Check the second order. 6 point. So correct answer is second order. But few people have said first order. So this is what happened in your first mid exam also. Many of you attempted the problems but not succeeded till you are getting the answer. So that's why more than 80% of your class got less than 50 marks. More than 80% of your class got less than 50 marks. This is the only reason you are enthusiastic, but that enthusiasm not gone till end of your problem to get the answer. See, I can tell you one reason. For exams like university, for procedure they may give marks. But if you are attempting gate, the answer, if you are correct to locate, you will get score. Otherwise, what will happen? Whatever wrong answer you can choose. So the motive of till you get your answer is not maintained in the class. I'm sorry to say, many of you got very poor marks in the first mid exam. This is the only reason. The method you implemented is correct, the way you proceeded is correct, but ultimately what is the answer to be got is wrong. When you are not getting the answer, what is the need of doing all these things? It may be good for your internal exams or for the university exams, but to crack exam like GATE, you are out of the competition. But because you are not cracking the correct bit, what is the answer? The same thing happened. It's a second order, but just doing in a hurry way. First order you are almost two digits same, so you said answer as a first order. So we should get patience. Otherwise, this is the only problem. Only two or three people got good marks in the class. Rest of them are very poor marks. That I didn't expected from the class, but very unfortunate. Anyhow, at 3:30 I will give the answer scripts. I will tell you the key also. Check out the key. Every objective question, every descriptive question, I will give the answer. Check in your answer booklet, quiz as well as descriptive. And if you have any discrepancy, you note it down and tell me. I will re-evaluate. Otherwise, whatever the marks you got, that is the final marks. అంతే కదా, చివరి దాకా వెళ్ళాలి మనం. స్టార్టింగ్ చూడగానే వేసేయడం ఫార్ములా చేసేయడము, టక 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 నొక్కేయడము అయిపోయా. ఫైనల్గా ఎంత రావాలో అంత రాకపోతే తప్పే కదా. నువ్వు ఎంత ప్రొసీజర్ కరెక్ట్ అయినా సరే, ఇక్కడైతే ఇస్తారేమో మంచి ఎగ్జామ్ కొట్టాలి, మంచి జాబ్కి వెళ్ళాలంటే రావు, అక్కడే ఉండిపోతాం. క్లియర్? సో దిస్ ఇస్ సెకండ్ ఆర్డర్ ప్రాబ్లం, నాట్ ఫస్ట్ ఆర్డర్. ఫైన్. The time for half change, the time for half change of a gaseous substance the time for half change of a gas, of a pure gaseous substance undergoing the thermal decomposition, undergoing thermal decomposition was determined for various initial pressures P. The time for half change, that is T half, for a pure gaseous substance undergoing the thermal decomposition was determined for various initial pressures with the following results. Find the order of the reaction. formula చెప్పండి. Concentration formula చెప్పండి. Concentration is equal to CA is equal to CA is equal to what is PA? What is PA? Partial pressure. Keep in the mind it's a partial pressure. The problem given is total pressure. This is what you people will do the mistakes. We should discriminate what is small p, what is capital P. I told you already what is small t, what is capital T. What is small k, what is capital K. Now it is not partial pressure given in the problem. Now you justify how to attempt. See, if that is partial pressure, absolutely whatever she said is correct. Because partial pressure is proportional to concentration because CA is equal to PA by RT. If you divide R and T, no need, no issue, so it will be CA. So if that is the CA, you know the expression for T half versus CA naught, you know that, fine, that's okay. But now the problem given in terms of total pressures, not the partial pressures. See, the people who are attempting the gate should be very cautious of the things. He given initial pressures as capitals. That means total pressures is given. Total pressures only, but initial pressures is given. Now you know concentration is equal to partial pressure by R. That you know. No, there is one more statement given. Pure gaseous. What do you mean by this? Pure gaseous. You have studied chemical quantum calculations. What is pure? What is pure? No impurities. That means what? No impurities. That means what? If I start with component A, only component A will be there. There are no other components. No inerts, no impurities, nothing. Only A is there. Pure. When only A is there, where is the logic of partial pressure? What is the meaning of partial pressure? What is the meaning of partial pressure? If I have so many components, component pressure but the total pressure is the partial pressure. Partial pressure of component A, partial pressure of component B. In this mixture, what is the partial pressure? I will talk. I am having only one component. Then your partial pressure is equal to total pressure. Pure gaseous. No other components, only A. Only A means where is the meaning of partial pressures? Will comes into picture. If I have two or three components, I will get okay partial pressure of this component, partial pressure of this component. But existing is only one. So my partial pressure is equal to total pressure. So my initial pressure is equal to total initial pressure. So is it not your initial partial pressure? Initial partial pressure is equal to initial concentration. Now C is correct. But this much of explanation you should know. Now whatever she said, the answer is correct. Because if that is the case, if these are like these are, if these are initial concentrations for different T halves, the answer is correct. Second order. But this much explanation you should have in your mind. Problem given is pure. That means other components are missing. If other components are missing means what? Only existing component is A. That will be your pressure. No meaning of partial total. Only one pressure only. So he mentioned as initial pressure means initial partial pressures. Initial concentrations. Because you know Ca is Pa by Rp. Almost concentrations are same. So now you know the Ca naught data. Now you know the T half data. You know the expressions for T half and Ca naught. Fine. First order, second order. How How quickly she has told? So when concentrations are increasing, your pH is decreasing. Now I already told, this trend will work for n greater than 1. Why it is exactly 2 then? Because I told you, T half Ca naught inverse relation is for n greater than 1 case. So n greater than 1 means n may be 2, n may be 3, n may be 4. But exactly how n equal to 2? We have done the problem, na? Why you are looking like that? For second order, T half is equal to 1 by. So use that expression, use the value, estimate some k values. If you are almost getting the same means it's a second order. Can't you check that? Ah, I can give you one more hint. T half is proportional to 1 by Ca naught. See, for second, see, I am giving one more hint for you. Because if you are really want to crack it, let's look at this. T half is equal to, T half is proportional to 1 by Ca naught. That means what? T half, if I multiply Ca naught, that will be constant for second order. That means you multiply this Ca naught versus T. These two you multiply, keep a table here. These two multiply, keep a table here. Because if it is a second order, T half into Ca naught should be constant. Are you getting same constant value? Check here. Check the value. Multiply T half and T naught or Ca naught. What is the value? You put the values here. Are you getting same 34,000 all? Yes, you just note down both of the keep the values. T half multiplied by Ca naught. Keep the values. Almost same. There ends the matter. There ends the matter. Very easy to crack. Only thing is you should know fundamentals very strong. If your fundamentals are strong, you can easily get gate. So whenever in any problems pure is mentioned, then you should have quickly in the mind the partial pressures equal to total pressures. Because there are no other components existing. Clear? One more other point in the previous problem. Whenever anything at the infinite given, that will be equal to initial. Before problem what we have solved? Volume at infinite time. Is it not the initial which you took will be the volume at the infinite time? So we should have correlations like this. That's called fundamentals. If you are good at your fundamentals, you can crack any exam. Okay. So it's a second order. Now fine. For the nth order T half relation. What is the relation for T half versus Ca naught for nth order? I just written T half Ca naught over. If anyone asks you to derive that relation, I just written T half proportional to Ca naught per 1 minus n. Now if asked you to derive, You can derive now. What is the problem? What is the nth order reaction? Nth order reaction rate minus R is equal to KCA power N for constant volume minus R is minus dCA by dt minus dCA by dt is equal to K into CA power N. What is the definition of T half? The time at which the concentration will become half of its original value. When Ca is equal to Ca naught, your T becomes T half. That you can substitute and get the expression for T half. So that is there in page number 48 in your Levenspiel textbook. Note down page number and you cross check the derivation part. So very simple derivation. Only thing is you just check and do the integration part. Okay. Levenspiel page number 48. Levenspiel page number 48. Now, I want to give one more derivation part because see, I don't want to put more time in deriving here and wasting the time. So the derivations, plugging, you can do it on your own once your concept is very clear. See, the small integrations can't you do at your home? Can't you do at your home? So parallel reaction I already told. Now can you derive the same thing for series of reactions? Series of reactions means when I start with A, R will be formed and it is in series to form S. This is called series reaction. Parallel reactions I told you. Parallel reactions I told you. I give an example also. What is desired, what is undesired. Component A only A, it will form either R, it will form either S. That's called parallel. The desired one we will keep it, undesired one we won't keep it. So in order to improve the desired rate, what you have done? If I want to have only desired one, what I have done? So I focused on rate constant. So how to improve rate constant? Include the catalyst. Include the catalyst that I told you. So that is the parallel concept. Equations already known. We have done the problem also. Now I want the series reaction. A gives rise R gives rise S. Now what is the expression for this? So can you write date expression for A? You can write. Then you can do integration. That's what we have done for first order. You have done integrations. So after doing some manipulations, you will get some final expression. Like for parallel reaction, what is the expression? Minus ln by Ca by Ca naught is equal to K1 plus K2 into T. That is one expression. Second expression is similarly you will get similar expression for series. Parallel is over. So I don't want to do for the series because I already told what to do, how to manipulate, how to do integration, how to get. So this derivation is already there in the textbook. So you can go through that. And just I am writing the final expression for series reactions so that we can solve some problems on the series steps. If any reaction is going series E, that means what? In series means what? You start with A, after some time you will get R, but after some time you will get S because R is also forming S. So look at carefully the reactions. Series reactions are very dangerous reactions. Very dangerous. You start with A. I thought R will be my product. R will be my product because A is consuming to form R. But what will be there? R definitely is a product. But after some time, R will not be a product. R will be a reactant to form S. So ultimately the product is yes, but not R. Because what is happening? After some time, R is also consuming. R is also consuming. So R will become the reactant rather than a product. It may be a product for only A. It may be a product for only A. But it is a reactant for S. Because how S is formed? Only if R is there. How R is formed? If only A is there. So that's what is series. If there is no A, there is no R, there is no S. Is it clear? So the intermediate product R will act as a reactant for S. Okay, so can you note down the expression of series reaction so that we can solve attempt some problems of series reaction? So derivation part I am leaving to you. So just go through the textbook, leave and see. Okay, so in your notebook you note it down, derive and combine and extract. The derivation part very easy. No need to do the class. If you have any doubt, you can leave me. If the derivation is difficult. So note down the expressions for series reactions. For series reactions, oops, time is over. Okay, so let's note down the expression. Ultimately, there are two main expressions for T of T max is equal to ln K2 by K1 by K2 minus K1. This is the one expression for series reaction. And one more expression is CR max by CA naught is equal to K1 by K2 whole power K2 by K2 minus 1. See, these two are very important derivations I am leaving to you. Everyone has to derive on their own. If you have any doubt, so that tomorrow we'll solve problems on these equations. Okay, look at the textbook. Textbook, the derivation is clearly given. Only thing is you follow and make a step and derive. It's almost like opening the banana only. Only thing is we should know how to open. So already there in the Levenskill textbook. Just cross check. Derive. Note it on your notebook. Because when you have in the notebook, you can refer once again. Otherwise, textbook is textbook and we are we. That's all. Okay. So be here in classroom at 3:30. I'll give you the answer scripts.